ஜெயபிரசன் என்னோட வாய்ஸ் ஆடிபிளா இருக்காப்பா?
எஸ் மேம்.
ஆடிபிளா இருக்கா?
எஸ் மேம், ஆடிபிள் மேம்.
ஓகேப்பா. ஸ்கிரீன் ஏதாவது ஷேர் ஆயிருக்கா? விசிபிள் ஆகுதா?
இல்ல மேம், ஸ்கிரீன் எதுவும் விசிபிள் ஆகல மேம்.
ஒன் செகண்ட். செக். நான் இப்போ ஷேர் பண்றேன். ஷேர் ஆச்சுன்னா சொல்லுங்க.
ஓகே மேம். ஷேர் ஆகுது மேம்.
இப்போ ஷேர் ஆகுதா?
எஸ் மேம்.
ma'am.
Yes, sir.
12%
Start பண்ணலாமா sir? Okay, sir. Good evening, everyone. I welcome you all for the Renewable Energy Club event guest lecture on smart grid technology as a renewable energy source. First of all, I thank our management, principal, vice principal, our HOD, and Dr. S. Tirunyanam sir, Professor, Mechanical Department of Srm VEC, for giving their guidance and support for conducting this Renewable Energy Club event. Srm Valliammai Engineering College, a division of Srm Group of Educational Institutions for Privileged Learning, is functioning under the Valliammai Educational Society with a noble vision of educate to excel in social transformation since 9/9/1999. The UGC New Delhi have granted autonomous status and SRM VEC offering two programs, namely Engineering and Technology and Management, with 11 undergraduate courses and 8 postgraduate courses. The Electrical and Electronics Engineering program is duly approved by the AICTE and affiliated to Anna University, Chennai. The department is ISO certified and NBA accredited for a period of 3 years. The department also offers postgraduate program in Power Systems Engineering since 2010. Now I call upon Mr. K. Jayaprasanna of Final Year EEE for giving intro about our resource person. Jayaprasanna.
Ma'am. I'm audible, ma'am. Mr. C.Nithya Sree is the alumnus of our college and is working as an application development associate in Accenture Solutions Private Limited, Bangalore. She has done the certification courses on AutoCAD for Electrical and Electronics Engineering by CAD Centers and Project Management by Management and Statistical Institute. She has completed the course on Electrical Vehicle Powertrain Fundamentals by Decibel Labs, hands-on training on hardware development using embedded systems, industrial automations, PSCAD, and courses on spoken tutorial Java certified by IIT Bombay. She did a project on a modeling of lithium-ion battery management and a monitoring system enhancing e-vehicle performance. I feel very happy to invite Mrs. C.Nithya Sree onto the platform so as to get an opportunity for all of us to listen to the speaker.
Thank you. Am I audible? Am I audible, Jayaprasanna?
Nithya Sree audible.
I am immensely pleasure to be a part of this guest lecture titled Smart Grid as a Renewable Energy Resource. I immensely thank our respected head of the department, staffs, and student community for inviting me for this guest lecture, and thank you, Prasanna, for your introduction on my credentials. Now I take upon the stage to present my guest lecture. Hope my screen is visible, and please do interrupt me if in case of if there is any audio issues from my side. Thank you. Let me start. So the topic of the day is smart grid technology as a renewable energy source, which is like familiar to most of you people here, but still I'm here to give you a high level information on the guest lecture topic today. Today everything is becoming smart: smartphones, smart TV, smart IoT devices, and all, smart homes, smart cities, everything is becoming smart. So what actually is the need of smart grid, and how can we integrate the renewable energy source into the smart grid technology is what we're going to discuss about. Before we dig deep into what actually the complete topic is, I'm going to break down our topic of the day into two technical terms involved, which is smart grid and renewable energy. Most of you might have been aware with the term renewable energy, like it is an unconventional source of energy. It keeps on replenishing and The nature gives us all the renewable energy for us to use without any limit, like the solar, wind power, and the hydro energy, biomass. All these are completely available all through the year, but there is some constriction in case of the time, like when in consideration of the PV electrical solar grids, you see only it is available during the daytime of the day. And this when the sun shines bright, or maybe only when the sun is there for us to absorb the electricity, absorb the heat and produce electricity. In the case of wind turbines, only when there is the wind blowing faster, at least to some speed, only then we are able to generate the electricity. And the same is the case of hydro, only when there is a particular parameters met, we are able to get the renewable energy. But one advantage is it is going to be, or it is going to be with the humans until our existence. So this is one set of information about the renewable energy. But while diving towards the smart grid, what actually is a smart grid? Before we dive into dive into smart grid, I'm splitting the term smart grid into two other sessions. That is smart plus grid. What actually is smart? Smart actually is an acronym which stands for self monitoring, analysis and reporting technology. Every technology which has this feature of monitoring itself, analyzing and presenting the reports, termed as the smart technology. There is smart IoT, smart cars, smart TV, smart cities, smartphones, everything which involves this kind of three things: monitoring, analysis, reporting, and much beyond. So all these are termed under the term smart, which actually means which is going to give the objects or whatever uses this technology to give it a cognitive awareness, means to think, remember, to act with reasoning, or what smart technology is all about. And this majorly consists of the technologies which include IoT, artificial intelligence, vision, and data analytics. And it's not just confined to all these technologies which are making use of smart. Now, what actually in terms of electrical defined as a network which connects the three portion of electrical power generation. That is, we generate the power electricity, we store, we transmit and distribute to the utmost level of consumption. Like from the power station, it is transmitted to the consumables, like whoever consumes, may it be residential area, industrial area, commercial area. This process is happening all the time. So what actually happens? It takes the power from the generation unit and transmits it through the conducting cables and distributes it to the industrial and the residential area. What is the need for this grid? This grid is going to help us make the best use of the resources and ensure security, which makes the system safe and reliable. This is in the case of just a electrical grid. Now, what actually is a smart grid? This is what we are going to see now. Smart grid. What is smart grid? This definition is taken from the National Smart Grid Mission website, which states smart grid is an electrical grid with automation, which involves the technology of automation, which involves wireless communication and other IT systems, like the software required to run the smart grid, that can monitor the power flows from the points of generation, as the power station, whatever may be, it can be a thermal power plant, nuclear power plant, or any renewable energy resources like the solar, wind, hydro. The power which is generated in the generation station is taken to the very menial level of people. Like from the point of generation, it is taken to a very small home or any town and cities in the country. It can also go down to the appliance level. That if the point of generation is a thermal power plant, but what we consume in our homes and in other areas is we make use of the appliance level. That is, we use fans, fridges, washing machines, laptops, mobile phones. So everything is the consumption is taken to the very minimum level wherever it is possible. And what actually happens is it can control the power flow or curtail the load. Control means it can have the full control of how the power flows and where the power flows, or curtail means to restrict or to cut down the load to match the generation in real time or near real time. So everything what we are doing right now is like R&D, and it is trying to meet the real time, or at least very much 80 to 90% close to what a real time data gives us. Here, this image gives you a representation of like the smart grid, smart city, which is having solar panels, windmills, electrical power stations, and all in a city, which is like connected with the wireless communication. connected to the smart grid, which gets energy and the energy sources of energy from wind energy, solar energy, nuclear power plant, thermal power plant, and all other sources from where the electrical energy can be generated from. So we'll have an overview of what the smart grid technology. As we have already seen, smart grid is a combination of hardware and software. That is the software mechanisms which we use, the automation software, the monitoring and controlling software. That part is the software, and the hardware is the electrical grid, which is going to be a hardware structure. The combination of these two hardware and software technologies together make the smart grid as a complete technology. It can monitor the activities of grid connected systems. Since it is automated, it can have a complete understanding and analysis of how the electrical system is working, and can make predictions around it. It can talk about the consumer preferences of using the electricity, how it is being used, what type of consumer uses the data to the smart communication systems, which is smart grid. It is capable of providing electrical power from multiple resources, may it be a wind turbine, solar system, or in the future, it can also derive power from the plug-in electrical vehicles if they are coming into use very commonly by the people. Smart grid components. So there are few components which together makes the smart grid. There is another thing which is grid modernization, which is beyond the scope of the topic, but still, to achieve a modernized smart grid system, we need a set of technologies and appliances to make it a smart grid system, which includes intelligent appliances, smart power meters, smart power stations, substations, superconducting cables, and integrated communication. Talking about intelligent appliances, it can be anything which makes the use of the smart, the term which we used, smart. That is, it can monitor, it can sense, it can detect, it can analyze. For example, the smart sensors, the temperature sensor can help us understand how much of temperature has been in the boiler and how it can be reduced based on the requirement, or should it be increased. That can be monitored with the help of sensors and other intelligent based appliances. Smart power meters. Talking about smart power meters, it actually helps a consumer understand how much of electrical power energy is being consumed. A common layman will not be able to understand how the unit of power is consumed, how it is being priced, what the tariff actually is. But when there is smart power meters, it can be helping more crowd, because they'll be able to understand. It can be digital and analog, and people will be able to understand in layman terms how much electricity is consumed, how they can curtail the usage of electricity, how can they reduce electricity bills, and how they can conserve the electricity is can be helped with the help of smart power meters. Smart substations, as we have already mentioned, the use of electrical systems is being merged with the smart systems. Like, it is automated with the use of automation, like PLC, SCADA, and it is helping us to make a smart substation like the smart city. Superconducting cables. Previously, they were using cables which has to transmit power from long distance. The generation place will be at one place, and the one who consumes electricity. Hello. Is there any audio issues from my side? Hello?
Okay, you can continue.
Okay, thank you.
Okay.
Thank you. Superconducting cables. As we already know that previously there were issues like the power station will be at one end, and the people who consume would be at the other end. So the distance was being very much high, and the transmission losses will be more in case of few cables. And when there is superconducting cable, the amount of loss which is transmitted can be reduced. And even when we are using a number of resources, so once a power station is somewhere around 200 to 300 kilometers away from your home, and you're consuming electricity, it will take so much time, and the transmission losses will be also more. In case of smart grid, there will be a number of energy resources which can be in your locality. For example, you can have a windmill. Near there will be a windmill around 50 kilometers of your locality, or you can even have a solar power system installed in your own house. So the availability of energy and the range at which the electricity is available for you to use can be reduced with the use of the smart grid. Integrated communications, as I already mentioned, the software and the hardware together makes the smart grid. For example, the PLC, the programmable logic computer, the SCADA, all these softwares and hardwares put together make a smooth smart grid ecosystem. So we'll see a small diagram of how the actual flow of electricity is. Generation, it can be from a nuclear power input or cross-border interconnection. And the another one great advantage of smart grid is that it is not just defined or constrained to a location. It does not have a state-wise thing. So only Tamil Nadu uses this amount of energy generated. So that state uses, this country uses. So it is not confined to a locality or for a boundary. It can be in a global level, in a globally integrated, and that is one main advantage of using the smart grid. And this is one connection, that is cross-border interconnection. It can be within cities, states, countries, or even continents. This is the local generation which is done in near our locality, and this is one source of renewable energy, which can be windmill, solar, and whatever which is of renewable energy source. And from there the electricity is transmitted. Also the data, as you can see, the power network is the orange straight line, and the telecommunications are the dotted green lines. The data is again transmitted. Data is transmitted to the transmission and distribution unit, where we have grid automation and the intelligent substations, which makes use of the software and hardware, making it easy for the analysis and the reporting purposes. From where it is taken to two types of places majorly. So that is, one is going to be the residential area where people live, and commercial industrial places where the business and the manufacturing takes place. In the residential area, if you consider, there are smart control and smart appliances, which can be integral, which one house can be a part of the smart city. And home display unit, as we have already mentioned, the person who lives in the house would be able to see how much of energy is generated or how much electricity are they consuming, how can they curtail the use of technology, can all the use of energy all can be seen through this home display unit, which is installed in their own home. And they can also store the energy. If in case the owner of the house is making solar energy out of installing the solar panels, or if they are able to make some kind of renewable energy, they can store the energy and they can give it to the they can contribute their part to the smart grid and the electrical distribution. In case of commercial and industrial, we have the electrical vehicle charging stations, energy storage, which has to be used if in case of power cuts or blackouts, and distributed energy management. What DEMS is, there are number of, in case of a smart grid, there are number of energy resources available. As we already mentioned, there are thermal power plants, nuclear power plants, renewable energy, solar, hydro. So all this energy is collected in the DEMS system, and it is equally distributed based on the supply and the demand. So this is distribution generation, where again the generated energy is distributed to people based on their need and requirements. Here you can see a transition of the smart grid technology from the traditional grid. You can see it is centralized. There is no connection. It does not form a loop. It just starts from a point and ends at a point. There is no way for the power to come back. That is, there is only one-way communication in case of a traditional grid. And when it is transitioned to a smart grid, you're able to see a number of electrical energy generations are there. There is a windmill, there is a solar power plant, thermal power plant, nuclear power station, hydro power plant. From there, the energy is taken to different units. It is taken to an electric car. It is taken to a home. It is taken to an industry. It is taken to other commercial purposes. And in turn, the people from the home or the electrical vehicle are also giving back their contribution to the electrical ecosystem by contributing their share of maybe solar energy or wind energy. They are contributing their contribution to the electrical system, which makes the system a two-way communication in comparison with the traditional grid. So what actually has been the change from a traditional grid and the smart grid? As you can see, there are few but larger power plants. There will be few power plants located at regions which are very much far, but there will be, in case of numbers, will be very few, and it will be placed in location which is very much far away from the residential places who use the technology, who use the electrical energy more. But now in this case of smart grid, there are a number of small producers. They can produce windmill energy, solar power plant energy, hydro energy, nuclear power energy, biomass. Everything can be generated, but there are a number of producers in a small scale. In case of traditional grid, it is centralized. That is, it does not form a loop. It starts from a place and ends at a place, and it is completely into a nation. Only a nation uses. But in case of smart grid, you can see there is decentralized and there is no boundaries. It can have an inter-border connection, which helps a global integration of electricity. And in the case of traditional, there were large power lines and pipelines. And as I told, the distance between the generation and the consumption is very large, and that was the case of traditional grid. And in the case of smart grid, there are small scale transformations, like as I already mentioned, there will be a solar power plant near you, or maybe a windmill which is nearby your locality, and the energy from there can be used. And if in case if it is excess, you can also store and make use of it in the future requirements. And it is a two-way communication, that is top to bottom. Top to bottom means it is generated in a station and it comes down to a level of home or residential purpose or for an industrial purpose, and it ends down there. But in the case of smart grid, we can have a two-way communication. The power generation station can give you electricity, and in back you too can give the electrical energy to the substation, and you are an active participant in the smart grid technology. Here, in case of traditional grid, you're only a passive person and you can only pay the bills for which amount of electricity you're consuming. And in the case of smart grid, you can also be an active participant by contributing your share by either giving back the energy or by storing the energy, helping in the case of blackouts or any other problems concerned. So here is a general comparison between the parameters and the infrastructures which is used for a traditional grid and a smart grid. In case of metering, it is electromechanical, solid state, which is of a conventional one, and now it is digital and microprocessor, which is more of a move towards a digital world. Communication is one way, and it is between a city or a country or a nation. And in case of smart grid, it is going to be global, and it is a two-way communication. Customer interaction, as I already said, once the power flows come from the generation to people, it is limited. But in the case of smart grid, you still have the conversation or the communication between the person, the electric person, and the power generating stations. And generation, it is centralized. Here it is centralized and distributed generation, where you can gain electricity from the other renewable resources and whatever possible ways of producing electricity is. And in the case of power flow, it is limited protection, monitoring, and control systems are very much in comparison with the smart grid, it is very much limited. But in the case of smart grid, you'll have a wide area monitoring, protection, and control systems, and here you have adaptive protection. In case of monitoring, there is negligible or there is no monitoring at all. But in the case of smart grid, since it is a smart technology, you have the self-monitoring capability. Restoration is manual. In case of traditional grid, when there is a power cut or whatever failure, the workforce has to go in person and restore the system back. But in the case of smart grid, if there is any problem, the software itself tries to self-heal the problem. If not, it sends an alert to the workforce, and the workforce can identify what problem it is, and they can easily restore in a very much a short span of time. Operation and maintenance, you have to do it manually, but since it is a smart grid with the digital integration, you can make the monitoring of equipment remotely from the comfort of a system or in an office. In case of control, it is a limited control system, but in smart grid, it is a widespread control system, which is pervasive control system. And the reliability is, it can be easily prone to failures and blackouts. But in case of smart grid, it is not completely like you can predict what happens the next day or within a 1 month, but still you'll be having very much predictive data, like 18 to 90%. You'll be able to analyze what is actually happening, and you can have foreseen situation which can help make the restoration easier and more faster. Topology is radial. Radial means it starts from a point and ends at a point. There is no loop concerned, and it just the network. It is to the place where the demand is high, and the supply can also be balanced if in case of any unseen situations. So now, what actually is a smart grid management of renewable energy? How the smart grid is making the best use of renewable energy? As I've already seen through few slides, renewable energy like solar, wind, and hydrogen is being the energy generated from these power generation stations are integrated to the smart grid, and this can make the smart grid a more sustainable form of electricity generation. And the renewable energy revolves around mostly gathering data. So able to predict and report the instances which is for unforeseen, and you'll be able to make it a little bit more automated and make optimize the best use of electricity. In case of wind farms, use the mechanical gears, and if a sensor has been installed, it will be able to note the current climate condition. So if the sensor is predicting that the climate is cloudy, so there will be a predicted rainfall, so they can plan accordingly. If in case of a solar power plant included with the sensor, they'll be able to predict. So if the sun shines bright, so okay, we can install more grids, or maybe if there is a rainy condition, they can make asset management accordingly, so that it is the smart grid and the renewable energy is integrated, which makes the best use of all possible ways of asset management, resource management, and whatever possible ways. So these three terms are mainly greatly integrated with the smart grid, which is digitalization. As a number of data collection is happening with the telecommunication and the wireless communication systems, real-time data and insights are being generated from the smart grid. And decentralization, that is, as we have already seen, a customer is becoming a prosumer. Prosumer means producer plus consumer, which is the consumer is actively participating by contributing his or her share, also getting back what they require as a citizen of that state or nation. Decarbonization, as we are mostly trying to use the renewable energy resources from the distributed energy resources, we are moving towards a sustainable future, which also helps in the decarbonization problem. Why should we use a smart grid? So this smart grid, as we've already seen, it helps with the monitoring, measurement of control power flows in real time, which can contribute to the identification of losses. If there is any problems, at least it can predict in way ahead and tell us what actually is a problem. Again, we can make appropriate managerial actions, or workforce can be actually trained and taken to the place if in case of any problem is arising. So it can also help us reduce the P&L losses, which is transmission and distribution losses, peak load management. So we'll be familiar with the terms, like at times with the electricity consumption will be very high, like morning 8 to 9, everyone goes to school, college, office, and the load at that time about 8 to 10 a.m. will be more. So large amount of load is required at that time, and when there is a different shift towards the other part of the days, that can be the variation in the amount of load which is being used. So that can be managed properly with the help of the data and insights which has been collected. They can make the best use of the assets. It has increased reliability, and renewable energy integration is done, and the accessibility to electricity as the end consumer is better in case of a smart grid. And it can also help leading to the self-healing grids, as we have seen that if it is detecting any problem, it tries to rectify itself. If not, it is trying to send the alert to the person who's at the other end, and makes the restoration more faster than in comparison with the traditional grid. As we have seen, this prosumer's terms is related by you can be the consumer end can become a producer and a consumer, thereby leading to a sustainable development and energy conservation. What are the benefits of smart grid deployments? There are a number of benefits in case of if we are installing smart grid, and one such is integrated isolated technology, where we better manage the energy which is generated, and the protection is higher in case of an emergency situation, and the demand for energy is highly met if in case of there is complex and critical solutions required. Reduction of transmission losses and the power purchase cost is reduced. It can actually satisfy the customer in a comparably higher way, and renewable energy can be integrated. Electricity access can be in a pretty much higher standard in comparison to the traditional grid, and increased grid visibility, self-healing grids, peak load management and reliability, better supply and demand response. With the amount of data which is collected, they'll be pretty much able to access what actually the supply is and the demand is, and they can manage the load accordingly. Better power quality and asset management. Mainly, it reducing the carbon emissions, which is going to be one important thing for a near future. This is just a pictorial representation of the generation, distribution, and the transmission of electricity while using a smart grid. features of smart grid is that it helps in real-time monitoring of system, and if there is any outage, they can be fastly restored, dynamic pricing mechanisms, and this point is what I told you previously, incentivize consumers to alter usage during different times based on the pricing signals. So if there is a peak, there will be some times where when the peak when the peak load is high, and the charges for that load will be in a higher standard. When the amount of energy required at sometimes will be low, so you can manage accordingly when to spend most of your time using the electricity with the less charges, and to reduce your consumption of electricity during the high price ranges. You can another advantages, you can better manage your energy, and in-house displays, you can have web portals and mobile apps to track and manage how much of electricity is consumed, how much can you curtail the usage of electricity to conserve and reduce the usage of electricity, and conserve your bill amount. So as a part of a summary, so what the smart grid is, it is an electricity grid enabling a two-way flow of electricity and data. As we have already seen, the smart grid is going to be two-way communication, which includes electricity and the data, which is collected through the wireless communication systems and the software involved in it, with the use of smart meters, which measures the energy and the amount of electricity, the units we use, smart appliances, renewable energy resources, and energy efficient resources, which will be found in the near future. And this can also benefit in the improved efficiency and the reliability of electrical supply, and it can also pave way for the electrical vehicle, the growth and the boom of electrical vehicles in a better positive, and it can help create a good environment. And the statistical data is that by 2023, 65% of the electricity companies will be investing in digital technologies, as there are a number of smart appliances involved in this, like smart meters, smart appliances, and several other smart technologies are getting into integrated into the smart grid, and the use of digital technology is being higher, and the investment of the electrical companies will help them in the near future to activate a load potential of about 35% of the installed capacity. It's just a statistical data. Okay, I would like to conclude by telling some quote which is related to a topic of the day, that is, take the self-driving car which is going to be coming in the near future, and the smartphone, and put those data together and think about how to manage a smart grid, because suddenly you'll have all of this data coming from those two mechanisms that allow for a higher level of allocating energy much more efficiently. Like as we've already seen, whatever we make use, maybe our daily usage of any applications or social media, whatever we use, the number of data which is generated is going on exponentially, and the data which is collected is going beyond the population. So it is growing at a faster pace, and there will be suddenly a lot of data will be there, and we should be able to make use of data efficiently, and make the best use of energy, and make it more efficient. Um, I'm done with my lectures, and if you have any questions, you can shoot out, and I'll try my best to answer those questions with the knowledge I have.
Thank you, Nithya Sree. Dear participants, if you have any queries, you can ask now. Students, if you have any queries, you can please ask now. Okay, I think students have no queries in this week. We will move on to the photo session now.
Thank you. Still, if you do not have questions, it's all fine. But still, keep yourself in a pace of learning, and day by day, start learning. It's not just about I know everything, but I am still a learner, and everyone make efforts to keep updating yourself with the new technologies, and stay up to date with all the information which is revolving around us, and will not be having enough time to consume all the data, and try to learn each and every day to increase your knowledge and skill sets. I extend my heartfelt gratitude for providing me an opportunity to be a resource person for the to the college I studied, and I take this opportunity at this juncture. I would like to thank the head of the department for providing me for the opportunities and the coordinators, Ms. Divya ma'am and Ms. Ilavarsi ma'am for providing me an opportunity to be uh, um, presenting this lecture, and all the staff members for providing your extended support by posting status and helping spread the word. And I'll be more than happy to take up any queries if I'm able to answer. And I'll try my best to answer to every one of you. And you can reach out to me at my email, which is mentioned here. Thank you. Have a happy Wednesday evening.
Thank you. Now I request our resource person, our faculty members and participants to switch on your camera for photo session. Kindly switch on your cameras for photo session. I request all the participants and faculty members to switch on your cameras for photo session. Only for few minutes, please. Thank you all. Now I request Mr. K. Jayaprasanna to give vote of thanks.
I thank Mrs. C.Nithya Sree for sharing her knowledge and views on the topic smart grid technologies as a renewable source energy source. We hope that our students are enriched with lots of information from renewable energy sources. Once again, I thank her for spending valuable time with us. I thank our head of the department, faculties, and students who joined the event. I thank you all.
Thank you, Jayaprasanna. Now we have come to the end of the session. I request the participants to fill the feedback to receive e-certificate. The link will be shared to your registered mail IDs and for external in the chat box. And for external participants, it will be shared to your registered mail IDs. Kindly fill it without fail in order to get your e-certificate. Once again, I thank everyone for your valuable visits. Thank you. So I will share the feedback in the chat box. So kindly fill it.
Chat box is not visible, ma'am.
Yes, yes. It will be shared to your registered mail ID also. Jayaprasanna.
ma'am.
Can you able to see the chat box? Have you
Yes,
received
ma'am.
the link? Yes.
Yes, ma'am.
For those who are not able to see the chat box, kindly check your registered mail ID. I have shared the link with you. HOD sir? Sir? Okay. We will end the meeting. Thank you for all your questions. Thank you.